Okay, so we want to take a look at this question here. It's question C-2 of the 2018 paper Ordinary Level Design and Communication Graphics. And it says there, the image on the right shows the newly opened Crossrail station in London's Docklands area. The structure is based on a parabola that has been shaped as shown. Figure C-2 below shows the plan, the elevation and the end view of a model of the front of the station. A 3D of the model is also given. Draw the given elevation. The vertex of the parabolic curve ABC is located at B. Draw the given end view. Project the given plan, clearly showing how the points on the curve are located. Hidden detail is not required and the scale is 1:1. So, looking at this drawing, it is a straightforward elevation, plan and end view question, a basic orthographic projection question. So we'll look at how we go about setting up this question and dealing with the solution. So first of all, I want to work on the elevation. So looking at the dimensions given in the question, I've measured over 35 millimeters, then 70, and I've broken that down into 35 and 35 and another 35. Now, again, be careful when you're looking at the question. When you're setting up, the overall height from the bottom to the top here is 110. And this bit here is 10 millimeters as well. So it's important to mark that 10 and then not to mark up another 110, because then that makes the question wrong. So it's up 10 and then 100. Now, inside this area here is where we're going to construct the parabola. And if we look at the question, we're told there that the distance from here to here is 120. So from the center, you measure out 60, and we measure out 60, and then we know that the height of this rectangle is 100 millimeters. Because it's 100, we can easily divide that into 20s, into 5 equal parts at lengths of 20 millimeters. So we measure 20, 40, 60, 80, 100, divides that into 5 equal parts. Do that on the left and on the right. And then we divide the top line here into 5 equal parts. And because the distance from here to the center is 60, the divisions that these will be divided up into are groups of 12. So 12, 24, 36, 48 and 60, and the same on the other side. So in the question we were told that B is the vertex, and it's important to identify that, because these lines at the side will always converge onto the vertex. So these points that we have marked on the vertical line coming up from A and on the vertical line coming up from C, we join those lines in to B. So once you have these lines joined into B, the lines there that we marked at 12 mil, you drop this one down onto the first line, get your first point, the second point, the third point and the fourth point, and you mark those points, and then you join those very, very neatly and accurately together with a freehand curve connecting C to B, as has been done here from A to B. And that completes the parabola in the elevation. So once you have all the points on the parabola, you complete the parabola and elevation. And then using the information and the dimensions in the question, you can project over the heights and begin to draw the end view. The separation between the elevation and the end view is 50 millimeters. That should give you plenty enough space. I haven't drawn the 90-degree angle there in the end view. There is a little construction associated with that, which will be explained in the next bit. So Once you have the elevation drawn, project across and draw the end view. Okay, so the distance from here to here is 55 millimeters, and we know that this point is up 35 millimeters and that this angle here is a 90-degree angle. Now, any time you see any mention of a 90-degree angle, you should instantly think of a semicircle, because if you join from the end of the diameter up to the circumference and back down to the same diameter, this angle here at the circle is always a 90-degree angle. So in order to solve this, we have to draw a semicircle. So the distance from here to here is 55. So you take your compass and you bisect this line. Where the bisector cuts the line there, 55 millimeters, that will give you the center point there for the circle. So you put your point of your compass there, you draw the semicircle here. And then you measure up 35 millimeters and you draw this line. And where that line cuts the circle gives you the point you're looking for. Join from here up to that point and back down, and you have a 90-degree angle here at the circle. Moving over to the elevation then, you can transfer the heights directly from the end view across. This line here is 50. This line here is 35 millimeters and this one here is 55. And the distance out then either side is 35 millimeters either side of the center line, making the length of this 70 millimeters. That then completes the elevation and the end view. As with all orthographic views, once you have the end view set up, you can bring all these points down onto the XY line, and they're brought back at an angle of 45 degrees down here to begin what is going to be the plan. Now, looking at the question, we can see we have a continuous line to here and back across the back and down here. So you can heavy in those lines, there's no reason why not to. Now, this curve runs flat across the bottom here for 30 millimeters. So you drop that down, bring that down to 45 degrees, and then that gives you this line here. And again, that's projected from this point down into plan, and this point here projected down into plan. Now, in order to get the points on the curve, because we need to get the curve now going from here and coming back to here, and how are we going to do that? Well, first of all, we need to number the points in elevation. And the most obvious thing to do is the points that we actually found on the parabola. We will use those points. It'll just make things much neater. So we start there at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Index those points in elevation, and we will proceed then to the next part after that. So where you have these lines in elevation at 9, 8, 7 and 6, these would also line up exactly with 4, 5, 2 and 1. So there's no need to bring those lines across. It's only unnecessary construction running across the elevation. So we bring those lines across onto this diagonal sloping line, because this is the curve we are trying to find in plan. So all of those projection lines come over here and they stop on this line. Now, you have to remember that you're in this position looking in at the end view, looking in at the plan to project the end view over here, which means you will see 0 first and 10 behind it, 1 and then 9 behind it, 2 and 5. So those points are labeled 0, 10, 1, 9, 2, 8, 3, 7, 4, 6 and then finally 5. Because what's happening here, it's starting there at 0 on the left hand side, going 0, 1, 2, 3, 4, 5. is the highest point, and then on the other side it's coming back down 6, 7, 8, 9 and 10. So once we have all of those points on that diagonal line, we drop them down then onto the XY line. They come back at an angle of 45 degrees, and you bring them into the plan. So the next thing that we want to do now is we want to go up into the elevation. We know that the points are going to be on these lines here in plan. So now we just drop down the points from elevation to intersect these lines. So once you've brought your lines down from the end view, if we start with this line here contains the points 1 and 9. So we bring that down 45 and bring it across. There's 1 in the elevation, there's 9. Drop them onto that line and you get your first 2 points. And the same then happens for the rest of the points. This is the line here coming from 2 and 8 that has 2 and 8 on that. You find 2 and 8 in elevation and you drop them down, and the rest of the points are found the same way. So you find all the points there from 1 to 10. Once you've found them all, we connect them together and join that curve. Now, we didn't have to put in hidden detail, but just for the sake of it, that baseline would be continuous across there, so you can put that in as a hidden detail line. The other thing to mention here is I've only put in the projection lines in colour just to make it a little bit easier for you to follow the drawing. When you're putting them on your own drawing, please make sure that they're just light lines, and that there shows the completed elevation, plan and end view of that question. So again, when you're finished the drawing and you have the elevation, end view and plan drawn, make the effort then for the presentation of the sheet. So label the XY line, elevation, end view and plan, the question number and the section it relates to, and a good title block put on the sheet. Okay, so that there completes that question.